Okay. Hello, everyone. Uh, First of all, if by any chance you can't hear me, could you give me some feedback in the chat? Otherwise, I think that we can start. First of all, thank you very much for joining me. My name is Andras Palfi, and I am a data scientist at Bigstep. So, if you haven't heard of us, basically our product is a big data infrastructure, and I'm going to show you a preview of it. So this is our data, and the webinar is going to be in a Jupyter notebook, which is hosted on one of our infrastructures. So if by any chance some of you are not familiar with what a Jupyter notebook is, it's basically a web-based Python text editor. So what it allows me, it allows me to run Python code in the browser. So this is what you're going to see during the webinar. Okay, so I think we can jump in. Yeah, so the objective of the webinar is to offer an introduction to the main types of recommender systems and the algorithms behind them. So as a result, I'm not going to focus on explaining every single line of code. Rather, I'll only be focusing on the parts that are central to understanding the concepts behind recommender systems. And I'll also make this notebook public to everyone who has signed up for the webinar, so you'll be able to go over my code and test it out for yourself. I also left a lot of comments and notes in a notebook, which hopefully are going to make it easier for you to test out the code yourself. So the webinar is structured into two main parts. In the first part, I'm going to go over some important concepts behind recommender systems, like the types of recommender systems, how we can structure recommendations as prediction problems, and also how we can evaluate the recommendations that we make. And in the second part, I'm going to show you how to implement some of these recommender systems in Python. So I think this is going to last around 25-30 minutes, after which we're going to have a short Q&A session. So if you have any questions, you can post them in the chat, and I'm going to try to answer them after I finish the webinar. Okay, so let's start. So if you ever find yourself browsing the movie catalog of Netflix, like myself, spending hours just to find something interesting to watch, then you face the exact same problem recommender systems are trying to solve, and that is helping us decide what to buy or consume. Now, the big question is, why is it so hard to decide what to buy? Well, first of all, oftentimes we don't know how to convey our own taste into words. For example, although we know what movies we liked in the past, we don't fully understand the factors that made us like those movies. And also, there are times when we don't even know what we need or what we like. Second of all, these factors are also exacerbated by a phenomenon called choice overload. It turns out that when we're faced with many options, as in the case of Netflix, we find it much harder to make a decision than when we're faced with only a few. So this is where recommender systems come into play. They intend to exploit the inefficiencies in our decision-making process by providing us with relevant product recommendation. And basically because they're trying to solve such an important problem, helping us decide, making decisions in terms of what to buy and consume, you can find them nowadays almost on any type of online shop or online platform, like YouTube or Netflix or Amazon is another good example. So now that we understood the main problem that they are trying to solve, I think we can take a look at how they work in practice. So there are two main approaches to building recommender systems. One of them is collaborative filtering, and the other one is content-based filtering. Now, collaborative filtering works on a very basic principle. Basically, people tend to like products similar to other products they have liked or purchased in the past, and also products that people with similar taste have liked or purchased. So as a result, collaborative filtering approaches employ the preferences of users to calculate similarities between users or products, and then use these similarities to make recommendations. So the main takeaway here is, I think, can be given by an example. So if my preferences are similar to that of another customer, it might be a good idea to recommend me products that the other customer has bought and liked, but I haven't. So this is collaborative filtering. On the other hand, content-based filtering algorithms rely on calculating similarities between products by looking at their attributes. So for example, in the case of a movie, attributes can be considered the movie genre, or the director, the cast, or even the year the movie was released in. And the way these attributes are used to provide recommendations is somewhat similar to collaborative filtering. Items that a user has positively rated are collected, and other items similar to these examples are recommended for him. So for example, if I watched the movie The Departed and gave it 5 stars, it might be a good idea to recommend me movies which belong to the same genre, or have the same director, or have the same cast. So basically, both of these approaches rely on an important concept, and that is user preferences. And there are 2 main methods through which users can express their preferences. One of them is implicit feedback, and the other one is explicit feedback. So in the case of explicit feedback, users manually provide feedback for the products they have consumed. For example, they can give a rating for a movie they have watched. On the other hand, implicit feedback is gathered from interactions users had with specific products. So for example, if a user has bought a specific item or clicked on a specific product or link, we can consider that interaction as positive feedback. Now, the majority of the recommender systems that are employed currently use this explicit, these type of implicit feedback data sets. So the first important concept to remember is that when building recommender system, we're always going to look at these type of user item interaction matrices. So this type of data is the starting point for any type of recommender system. Basically, you have users, and you have items, and you have some sort of interaction between them. Okay, so another important concept is that of similarities. Both content-based methods and collaborative filtering methods measure similarities between users or items to make recommendations. Now, in mathematical terms, these similarities can be expressed as measures of similarity or measures of distance between 2 vectors. So basically, these are formulas that come from either geometry or linear algebra. So as a result, we need first, before we can calculate similarity between users or items, we need to express them as vectors. And this is how you can do that. Basically, you have a user, and each cell represents a rating that a user has given for a specific item. So this is going to be, let me just try to do it. This is going to be a vector. And this is going to be another vector. So what you can do is basically calculate the distance or the similarity between these 2 vectors to decide how much alike these 2 users are. Now, what exactly are these measures of similarity? So I think 2 good examples would be the Euclidean distance and cosine similarity. Now, if you remember from geometry, Euclidean distance between 2 vectors is basically the shortest distance between them, those 2 vectors, while the cosine similarity is the angle between the 2 vectors. And basically, these are the 2 formulas that you use to calculate. So what you do when you want to get the similarity between 2 vectors, you just take those vectors, plug them into these formulas, and they're going to give you a number that's going to represent the similarity. And in the case of cosine similarity, it's going to be 0 if the 2 users aren't similar at all, or it's going to be 1 if they are exactly the same. Okay. Now, let me just clear this. Okay, so how can we structure recommendation as prediction problems? Well, there are 2 methods, basically. First, we are interested to predicting the rating values for user item combination. So basically what that means is we have a user and we have some items for which that user hasn't given any rating or hasn't interacted with that. So what we want to do is to provide a prediction for that specific rating. So basically we're going to fill out the empty spaces in this matrix, explicit feedback. Okay, and the other approach is that we don't want to fill out the whole matrix. We're not interested in calculating a ranking, calculating a rating for all the items. We're only interested in just finding the top end recommendations. So finding the top 10, let's say, movies that he's going to be most likely going to enjoy or going to watch, or the 10 products that he's going to be most likely to purchase. Okay, so this is how we make predictions. We basically make rating predictions, and now let's see how we can evaluate the predictions and the recommendations that we make. And there are two main environments through which recommender system can be evaluated. One of them is online, and the other one is offline. Of course, the best way to measure the quality of a recommendation is to actually see how a user reacts to it. And this can only be done when a recommender system is already in production. However, before we can put a system into production, we need a method to evaluate it offline. So for this, we're going to be using a measure called root mean squared error, which basically looks at the predicted ratings which basically takes the mean squared error of the predictions that you have made, and then takes the square root of that value. So just, I think, to conclude, and the most important idea is that usually the best way to test recommender system is to feed them to customers and get direct feedback on them. However, you cannot do that offline when you're testing your algorithm. So you have to use some kind of measure to see how well your algorithm is going to perform. Okay, so this was the theory part of recommender systems. Let's see how we can actually implement them in practice. And for this, we're going to use a data set that comes from MovieLens, which is a movie recommendation service. And this data set contains about 100,000 ratings across 9,700 movies. And these ratings were given by exactly 610 users, with each user providing a minimum of 20 ratings. Now, this Jupyter is running on Linux, so I can use curl and unzip to download the data set. However, if you're using something else, so you want to download manually, I also included a link that you can click on, and it's going to automatically download the data set. Okay, so this data set contains 4 CSV files. However, we're only interested in 3 of them: movies.csv, ratings.csv, and links.csv. So let's see what these 3 CSVs contain. And for this, we're going to use pandas. We're going to use to store our data in data frames. And then we're going to use NumPy as well to do operations on vectors. So basically, we read the 3 data set, and then 3 data sets into 3 data frames. And then we can concatenate them into a single one. And this is how our data set is going to look like. Basically, we have a column with movie ideas. We have a column with user IDs. We have ratings. We have the time at which specific rating was given. These are 2 links that we're going to use later on to retrieve the posters of movies that for the predictions that we're going to make. So we're going to visualize the recommendations that we're going to make a bit later on. Okay, so these are links. These are the titles, and of course, these are lists of genres that each movie belongs to. Okay. So first, we have to do some data preparation before we can apply any type of recommendation system or any type of recommendation algorithm. And I'm not going to go into a lot of detail what I did there. Basically, I just had to remap the movie ideas to make it monotonically increasing. So as you can see it here, it wasn't monotonically increasing. It didn't go from 1 to 2 to 3 to 4. And that's the only thing that I did to the data set so far. And I also saved into dictionary the mapping between movie ideas and movie titles. So I'm going to be able to retrieve the movie titles based on the ideas, their ideas. Okay, so we can also do a quick plot of the data set that we have. And I plotted the distribution of ratings, which tells us an interesting, just a second, because I want to check that if everything's okay. Okay, yeah. Yes, definitely. The notebook is going to be made available to everyone. Okay, so back to the notebook. So here you can see the distribution of ratings. And basically, there are two main takeaways from this. That users generally tend to give round numbers as ratings, and also the majority of the ratings are 3 and 4. And also the minimum rating is 1 and the maximum is 5. And also the distribution of the majority of the movies have very few ratings, and this is going to be an important thing to remember later on. So another important concept in machine learning is model validation. And this is mainly used to estimate how well a model will perform in practice. So, and this is done by splitting our data into a test set and a train set. And this of course, is done in every type of machine learning problem. You usually have a train set, which you use to train the algorithm, and you have a separate test set with data that the algorithm hasn't seen yet to estimate the performance of the algorithm, to see how well it's going to generalize to unseen data. And to do this, we're going to randomly remove 10 movies from each of our users and put those ratings in a separate test set. However, before we can do that, we need to create the user item matrix. And that's exactly what I have done here. First, I create an empty matrix, and then I populate it with all the ratings. So what I get here in the ratings matrix is a matrix where each row index is a user, is a specific user. So these are all users. And each column is an item. And the cells are ratings that a specific user has given a specific item. Okay, so let's clear this drawing first. So now that we have, so this is exactly the concept that I mentioned in our introduction. This is our explicit feedback matrix, what we have right here. Okay, so now what we can do is, using this function, we can randomly remove 10 ratings from each of the users. And that's exactly what I have done here. I built a train set that we're going to use to train our algorithms on, and a test set. Okay, so now we basically have everything ready to actually build our recommender systems. And the first approach we're going to use is content-based filtering. Now, content-based filtering algorithms rely on calculating similarities between attributes of a given product. And in our case, we're going to be using the movie genres as our item attributes. The first step in creating our content-based recommender is to calculate all the similarities between movies. However, to achieve this, we need to do some data pre-processing first. Now, I'm not going to go into a lot of detail here. I'm also only going to show you what we need to get. So what we need to get is basically a matrix where each row index is a movie idea, and each column index is a genre. And cells are 0 or 1, depending on whether a movie belongs to a specific genre. So this is how we need to represent our genres. We need to, basically, it's called one-hot encode them. And the way to interpret this, so for movie ID number 1, column number 1 is going to be fantasy. And if this is 1, that means that movie number 1 belongs to the fantasy genre, because the second column is drama. And this value of this cell is 0. That means the movie number 1 is not going to belong to the drama genre. Okay. Now that we have this matrix, we can plug it into a function that's going to help us calculate the similarities between all of the movies. So what this function does is basically takes all of the movies one by one and calculates the similarities, the cosine similarity between them. So it's basically going to plug in all these vectors into the cosine similarity function, and it's going to calculate the similarity between all the movies. However, the way it does this, it is using some linear algebra, and I'm not going to go into a lot of detail. I think you're going to be able to try it out for yourself. And after I apply this function, I basically get a movie similarity matrix, where each row index is a movie, each column index is a movie, and cells are similarities between movies. Now, that means row number 3 and column number 3 is going to be the similarity. Column number 1 is going to be the similarity between movie ID 3 and movie ID 1. Sorry for the terrible drawings. And so this is going to be also a symmetrical matrix, because similarity between movie number 1 and movie number 3 is going to be equal to similarity between movie number 3 and movie number 1. Okay. So now that we have this matrix, we can start making predictions. Now, how are we going to do that? Basically, we're going to use a method called k-nearest neighbors. Now, KNN is a very simple algorithm which calculates the ratings for a specific movie by taking the k most similar movies to it and calculating the weighted average of their ratings. So basically, if I want to make a prediction for a movie, I'm going to calculate, let's say, the 40 most similar. I'm going to look up the 40 most similar movies to it, and then make a weighted average of their rating to predict a rating. And this is exactly what this function does here. Basically implements the k-nearest neighbor algorithm and returns me a predicted rating for each movie that I give it. So now that we have all these functions, we have a k-nearest neighbors function to calculate predictions. We have all the similarities between movies. We can iterate through all the movies in our test set and predict ratings for them. And that's exactly what I have done here. I basically iterated through all the users and all the movies in the test set. And for each movie in the test set, I had made a prediction for it. And I saved the predictions in a matrix. Now, as mentioned in the introduction, after we made the predictions, we can measure the accuracy of our predictions by using the root mean squared error. And this function just simply calculates the root mean squared error between my predicted ratings and the actual ratings. And you can see here that the mean squared error of our prediction is 0.9. Of course, this measure in itself is not really relevant because you need something to compare it against to see if your recommendation performs better or not than some other recommendation system. And we're gonna do that. We're gonna see when we implement collaborative filtering how well those perform. Okay. So, however, prediction accuracy is only part of the answer. We would also like to sample a few recommendations in order to manually check their quality. And to do this, we need to build a data set which contains all the movies not yet rated by a user. So this is exactly what I've done here. I picked the user. Now it's user 113 with the ID number 113. And I predicted ratings for that specific user. So I predicted ratings for all the movies that he hasn't seen. However, I'm only going to be interested in the top 10 recommendations that just in the top 10 recommendations, meaning the movies with the top biggest ratings, because I don't want to serve him a list of 200 movies that he hasn't seen, because that's not going to be helpful. And now we can check. Let's check the movies that he has seen, and let's see the recommendations that we gave him. So I chose this user because he seems to have an interesting taste in movies. First of all, he's seen all the Harry Potter movies, I believe. He's seen some Star Wars movies. He's seen Monty Python, and he has seen some action hero movies like Spider-Man. And I think there was another Spider-Man somewhere here, and Deadpool as well. And he has seen some animated movies as well. So it's a very interesting taste. Let's see what our recommender system recommends him. So also, to make our analysis a little more interesting, we can view the movie posters for these recommendations. And I think that's a better way to visualize our recommendations. So what I do here with this function is basically I connect to the MovieDB API, and I retrieve the movie posters first for the movies that he has watched. So this is all the movies that he has watched. And these are the recommendations that we did him. So first of all, we recommended The Shining, which is a horror movie, Nosferatu, The Texas Chainsaw Massacre. So this seems very interesting. He hasn't watched any horror movies, and yet our recommender system tells that he should be watching horror movies like Dracula. Okay. So this was content. These were content-based recommender system. Let's move on to collaborative filtering. Now, collaborative filtering methods make use of user past behavior in order to recommend items. And this approach does not rely on item or user attributes, which are sometimes hard to collect. And there are two main approaches for making recommendations using collaborative filtering. One is the neighborhood-based approach, which is called also the memory approach. And the other one is the model-based approach. Now, the neighborhood-based approach can be divided into two main methods. One is user-item filtering, and the other one is item-item filtering. Now, a user-item filtering takes a particular user, finds users that are similar to him or her based on similarity of ratings, and recommend items that those users like. In contrast, item-item filtering will take an item, find users who like that item, and find other items that those users or similar users also like. So basically, in both cases, we're going to be using the user item rating matrix that we created in our previous section. Now, the same way that we calculated similarities between movies, we're going to be calculating similarities between let me just scroll up here. We're going to be calculating similarities between items, and then we're going to be calculating similarities between users as well. However, now for items, we're not going to calculate similarities based on attributes as we did with content-based. We're going to filtering. We're going to use ratings instead to calculate these similarities. Okay. Sorry if I'm scrolling fast. So I built, again, a function that's going to help us quickly calculate the similarity either between users or between items. And this is exactly what it does. It returns a matrix, a user similarity matrix, and an item similarity matrix. So the user similarity matrix is going to store no, not as previously, because this is going to store the similarities between users. Rather, the item similarity is going to store the similarities between items, just as previously. Okay, so now that we have pre-calculated all the similarity matrices, we can use them to make predictions. And we're going to employ the exact same method as we did previously. We're going to use the KNN algorithm. So we're going to look for the K nearest movies or the K nearest items and take a weighted average of their ratings to make the prediction. And here I'm going to make those predictions based on the train set, and I'm going to test that. I'm going to see how well those performed using the test set. And as you can see, we get two root mean squared errors. One is 2.8, another one is 3.22. And of course, at a first, these seem to be higher, if I remember correctly. These errors are higher than the errors that we had, with content-based filtering. However, like I said, it's not all about errors. We also should see and check these predictions manually as well to see how well they might look like. However, before we do that, I also want to go into a bit of detail of how to choose K. So choosing the right value of K in the K nearest neighbor. So basically what you can do is you can iterate through several different values of Ks and just see which one of them is going to minimize your errors. So as you can see, for user-based, the best value of k is going to be around 26, 27, and for item based, it's going to be around 15. Now, let's sample the recommendations that we have made. Okay, so the item based recommendations are these ones. So I made, again, I made all the recommendations. However, I only sampled the top 10 of them. And because that's what we're interested in. We're always interested in making the top N recommendations. We don't want to send him a list of all the movies that we predicted ratings for. And as you can see now, we have much, our recommendation is quite different compared to content-based filtering. And yeah, so one of the movies we recommended, I think, is Monty Python, because he has watched Monty Python, yeah. And otherwise, he seems to like fantasy movies, so I'm not really sure why our recommender system is recommending him a musical, for example, or recommending him a romantic comedy. I think this is a romantic comedy. Okay, so let's see. This was the item-based similarity recommendation, and let's see the user-based similarity recommendation. So the user-based similarity recommended him Ocean's 11, 20 Dates, Enemy at the Gates, Spirited Away. Spirited Away makes sense because he has watched a lot of animated movies like Shrek and The Incredibles and Finding Nemo. So that one does actually make sense. And again, we have 300. You can see 300 was recommended by both of the approaches. And ET and Minority Report, which for me, it doesn't seem intuitive why he might like this movie. But as in the case of recommended systems, you cannot really tell that he's actually going to like this movie, not going to like this movie. It's something that you have to test in real life. Okay, so memory-based algorithms are easy to implement and produce reasonable prediction quality. However, there's a drawback to them, and that is that they don't really scale to real-world scenarios, and they don't really address the well-known cold start problem. And that is when a user or a new user, a new item enters the system. However, on the other hand, model-based collaborative filtering methods are scalable and can deal with higher sparsity level than memory-based models. And I have a feeling that we're slowly running out of time. But if you don't mind, I'm not planning to go into a lot of detail with model-based approaches because they're basically based on using a lot of linear algebra. So I think that is beyond the scope of this webinar. However, I'm going to give you an example of how easy it is to implement a model-based recommender system using a very nice Python library called Surprise. So Surprise is a Python library that helps you, that implements a couple of popular recommendation algorithms. It implements collaborative filtering, but it implements quite a few model-based approaches as well. Now, what are these model-based approaches? They basically involve building a model based on the data set of ratings. In other words, we extract some information from the data set and use that as a model to make recommendations without having to complete the data set, having to use the complete data set every time. And just to see how example is to make some predictions using Surprise, it basically, I think you have six lines of code. I was able to get top N recommendations for all the users in the data set. And I also printed them out. And here you can, I think, yeah, here they're also visualized. So interestingly, our model-based recommender system recommended him Lord of the Rings, which to me seems logical because he has watched Harry Potter, so he likes fantasy movies. It also recommended him Shawshank Redemption, which I think it's not a bad recommendation in general because it's a very popular and very highly liked movie. But it's interesting to see that it was recommended to him. Another Lord of the Rings, the Godfather movie, another popular movie. Doctor Strangelove, Before Sunrise seems a bit strange to me. Donnie Darko, yeah, and Batman. Of course, he has watched a lot of Spider-Man and Deadpool, so he might be very interested in watching The Dark Knight and Logan as well. He's a fan of superhero movies. And Old Boy, I think, is a very funny recommendation. I have no idea why it was recommended to him. Okay, so I think that's it mainly for our webinar. I would like to see if you guys have any questions. I think you can ask them in the chat. Let me just start the chat. So if there was anything that you didn't understand or you want me to show you again how it works, I'd be more than happy to do it. Okay. Oh, wow. I did get a question. Okay, so the traditional, I'm going to read, I think everybody can see the question, but I'm going to read out loud so I can understand it. So what is the advantage of using either collaborative or content-based algorithms for recommendation instead of using traditional classification scheme? As a hypothetical example, let's say that in the movie analysis data set, we also have information about the age and country of the user. It would make a pipeline or binary classification for whether user interested or not in a specific genre. And after that, the multi-class classification for that movie is inside the genre the user would be interested in. Yeah, no, this is another way to make a recommendation. It's just a different, yes, it's a different approach to it, but it's definitely a viable method. But the thing with recommender system is there's so many metrics. This usually focusing on one single metrics is a very bad thing to do. You would be basically looking at not just calculating the error, because the error doesn't really, just because you manage to predict a good rating, it doesn't really mean anything about the user. You also need a couple of measures that are going to tell you how diverse your recommendation is, whether you are offering recommendations outside a specific genre, whether you're offering recommendations from your whole catalog or only just a sub part of your catalog. And I'm going to give you a few links to, I'm going to put a few links into this notebook to a couple of very interesting resources that going to go a bit more into detail on how to actually measure how good recommendations your system is making. I think this notebook is going to be a good, another question is where can a beginner start to learn recommender system? Well, I'm going to put in a lot of resources into this notebook, and I think I'm going to publish it as a tutorial. So I'm going to put in links to other tutorials or other websites, and I think that's going to be a good resource, a good starting point for learning about recommender systems. Yeah, so another question is usage of large stacking models for recommended. Yeah, yes, so this is a famous example. So Netflix for many years had a competition in which users had to make recommendations for the Netflix dataset, for Netflix movies. And it's interesting to see that the model ended up using, the final model ended up using like in a couple of hundred machine learning models. It was a blend and a stack of 100 different models. Okay, so we also have a Q&A tab, but I'm gonna answer this question in the chat first. So the winning solution for the Netflix prize ended up being a combination, a blend of like more than 100 models, if I'm not mistaken. And the issue with those systems is that it's impossible to put them into production. Like that's a production nightmare. Even though if they can win a machine learning competition where you're trying to optimize for 0.0001, it's not a system that's ever gonna be put to use in a real world system. So, and then Netflix never ended up using that recommender system that actually won the Netflix prize. I think it was a $1 million prize that the team has won. I'm going to put into a link into as well to the paper that discusses the Netflix solution. Netflix solution. Okay. So let's see the questions in the Q&A. So what types of systems have you seen in production? So unfortunately, I haven't seen any recommender system in production. I'm about to implement a recommender system in production. I just gotten some very interesting data set. Okay, do we take into account the frequency of an item? ABA with the item matrix for AAB1. Item matrix for AAB1. I'm trying to understand the question. I think item matrix, the similarity. Yes, exactly. So the similarity between this, exactly. So this is going to be, the similarity matrix is going to be a symmetrical matrix, and which along the diagonal is going to have 1 because an item is most similar to itself. Okay, so do we take the sequence into account? For example, if the user has viewed A after B. Yes, so yes. Of course, in complex recommender system do take these contextual information into account. So Netflix definitely looks at which time a movie has been viewed, or in which sequence the movies have been viewed. So these types of information definitely can be implemented and used in a recommendation system. Okay, and I think the last question I'm going to answer is from Y. And say we used a couple of approaches, and each approach produces a list of rank recommendation. What method can be applied combined into one list of recommendation? Okay, so that's interesting. Well, you could yeah. Again, that's a part of machine learning that's called blending or stacking, where you blend the results of different machine learning models or stack the results of different machine learning models. So, just as the simple example would be just to take a linear combination of all the ratings that are in those top end recommendations. Okay. So you get feedback. So you get feedback of the users when it's in production. So it depends on what type of feedback do you mean. When I said feedback, I referred to you serve some recommendations to a user, and you check whether he or she has reacted to them. So if you serve a recommendation to serve some movies, for example, to a user, then you're going to be able to see if he has seen them or not. And if he hasn't seen any of your recommendation, then you go back to your recommender system and try to look at the metrics and try to find out why that specific user hasn't looked at your predictions. Okay, so they are number based on words and paragraph. So a lot of questions. Yeah, I would love to answer all of your questions, but I think I'm going to stop here. However, I think I'm going to be able to answer your questions in mail, if that's okay. So if you have any other questions, please, you can send them to my email, or I think you can leave them here as well in the chat. But I think the best way to contact me would be through my email, which I'm going to actually leave into this notebook. So the way I'm going to share this notebook, I think I'm going to send you a link to my GitHub. I'm going to put this on my GitHub, and I'm going to send you this notebook, the link to this notebook. Okay, well, thank you for joining me, everyone. Ovidio, I'm going to answer to your question in a mail if you don't mind. So thank you very much, guys, for joining me. And have a nice evening.